Earth has changed so much over the course of its long history that when you look at what we know of the planet's history, snapshots of different periods of time, this world becomes very alien from what we were born into in this modern geologic era. Everything from its animals, its geology, its atmosphere, all of it has so dynamically changed across the natural history of Earth that you can pick times when the planet was molten to very nearly frozen over to much higher oxygen levels than now to much lower, and even a period where its atmosphere was radically different and would not have been in any way breathable to us. There was a time, if one were to go far enough back in time, this planet was deadly to us and our evolution was not yet possible despite the planet having life. And it will continue to evolve. In the far future, the ever-brightening sun will bake the Earth, boil its oceans away, and turn it perhaps into something more resembling Venus than its former self. And eventually the power of the sun will eventually force the surface of the Earth to return once again to a molten state, but not from youth and recent formation, but age and impending death as the inevitability of the red giant phase of the sun asserts itself. But one area that isn't often imagined in this is the night sky. All throughout natural history, the arrangement of the stars has changed from our perspective. Stars move, they exhibit proper motion, and move their own distinctive ways. And as a result, if you were to teleport back several million years, you wouldn't recognize the stars. You'd see the moon, of course, and the planets, but the stars would be radically different in appearance and not conforming to our modern constellations. But it's also possible that at some point in Earth's history, there may have been something more, a ring system, not entirely unlike that of Saturn. The physics of this idea are rather straightforward. So you have an asteroid that gets perturbed one way or another in Earth's direction, but it doesn't strike Earth. Rather, it comes just close enough to be gravitationally captured by Earth. But that same gravity is enough to shred the asteroid if it's past a critical point called the Roche limit. This may seem unlikely, but there are several relatively recent events in Earth's history that show that such close encounters may not be all that rare in the grand scheme of things. One such incident was the Great Daylight Fireball of August 10, 1972. On that date, a small asteroid, it would have been a meteorite if it had hit the surface, entered the atmosphere at 15 kilometers per second, basically just over 33,000 miles per hour, over Utah and made its way on a north trajectory until disappearing over Alberta. Producing sonic booms, the smoke trail from the object hung in the sky for a time after the event, but there was no corresponding meteorite because this object did not hit Earth. Instead, it grazed the atmosphere and then left the atmosphere again and continued on its way in space, sporting a nice fresh burnt fusion crust as a souvenir of Earth, courtesy of the atmosphere. Oddly, calculations done in the 90s predicted that this object would have still been in an Earth-crossing orbit after its passage, and there was an estimate that it would fly past Earth, but probably not enter the atmosphere again in August of 1997, but nothing was ever seen. It's anyone's guess where this object is now, but it remains likely that it still passes close by from time to time. The object is estimated to have been between 3 and 14 meters across, and probably represented a small Apollo asteroid, but after its encounter with the atmosphere, it was probably reduced to half or more of its original size. Had it not grazed, it very likely would have showered meteorites somewhere in northern Canada. Another event like this happened on February 9, 1913, again over Canada, the northeastern US, and even as far south as off the coast of Brazil. This one was even stranger. Known as the Great Meteor Procession of 1913, this event was noteworthy because it appeared as a sporadic meteor shower, containing between 40 and 60 separate events over about 5 minutes, amid detonations and rumbling. But unlike a normal meteor shower, astronomers could find no apparent radiant. Rather, they seemed to be positioned on a great circle arc, which would be more consistent with Earth capturing a small asteroid, ripping it apart, and then the chunks falling one by one into the atmosphere all on the same track. Oddly, the accounts seem to point to there having been a second meteor procession about 5 hours later, but given that Earth rotates, there isn't a ready explanation for that in this model if it did indeed occur. But in a way, even though the object in question was probably originally relatively small, had it been larger and in a slightly different orientation, it might have been ripped apart into a temporary ring system around Earth. Indeed, one hypothesis for the origin of Saturn's rings is that it was once a huge asteroid, large comet, or more likely a small icy moon, that was torn apart about 100 million years ago. Saturn is mysterious like that. Another hypothesis is that Enceladus is actually a relatively newly formed object somehow as well. There actually is evidence for some kind of event in Earth's history that supports the possibility of Earth once having had a ring system. It's thought that there was some kind of major collision in the main asteroid belt about 466 million years ago. And Earth's geology during the Ordovician period shows evidence of increased earthquakes and tsunamis, such that it looks as though Earth was getting bombarded by asteroid chunks rather than something inherent to the geology of the planet. But there is more. 21 buried fossil impact crater candidates on Earth date back to this time. And evidence in limestone strata shows the hallmarks of meteoritic material, not unlike the end Cretaceous boundary layer that marks the end of the dinosaurs at the hands of another asteroid 66 million years ago. The Ordovician craters stand out, so to accumulate 21 of them should take tens to hundreds of millions of years. But here it did not. The craters were all formed within a period of thousands to hundreds of thousands of years. That's very unlikely to be due to random chance. Something caused a bombardment of this planet, but the question is, what? So if the distribution were more widely scattered, such as from a hail of asteroid or comet material, it would indicate that. However, if the craters were arranged in a line near the equator, it would tend to indicate that the material was from a falling ring system. But there's a problem, and it's plate tectonics. Land masses move on Earth, and the Ordovician craters are no longer in their original positions from the time when they formed. Interestingly enough, researchers in Australia were able to rewind plate tectonics and reconstruct where the craters originally were. And it turns out they were all in a line within 30 degrees of the equator, basically the middle third of the planet. While not slam dunk evidence of a former ring system, it is solid evidence supporting the idea and disfavoring a group of random asteroid impacts. But then there are the chances of this happening. The asteroid would have had to pass within a very narrow region of space for Earth to shred it into a ring. But Earth has had billions of years worth of close passes of asteroids, so it's not that far of a stretch to consider whether it caught one just right to tear it apart and form a ring. Interestingly, it's actually possible that Earth has had several ring systems early on, because in the early days there were a lot more asteroids and cometary material around during the late heavy bombardment, but any evidence of rings previous to the Ordovician ring is long erased by Earth's subduction, weathering, and dynamic geology. But there is one period where it's very likely Earth had a short-lived ring system, and it was when Theia hit and threw off the material that would form the moon. It may have been a ring system before coalescing back together to form the moon. Interestingly, this may also represent Earth and life on it avoiding an even bigger catastrophe. The object, before it was torn apart, probably was similar in size to the asteroid that killed the dinosaurs 66 million years ago, in the class of 10 to 15 kilometers. Had it not basically been stalled by being ripped apart into a ring system, it might have hit intact to similar results as the end Cretaceous asteroid, followed by a mass extinction of some degree. Though it has to be remembered that oceanic life is less affected by impacts than land life, and there wasn't yet the enormous diversity of land-based life that there was during the age of the dinosaurs. But it might have caused an altogether different catastrophe, more on that in a bit. Instead, by forming a ring, it simply meant that the material fell in a less harmful way over time, instead of as one big mass. The ring, if it existed, probably would have persisted at least several million years, and probably would have appeared as a faint band during daylight, and to some degree a softly glowing band at night. This was not something life on Earth probably would have directly noticed. Indirectly, however, the ring would have blocked a percentage of sunlight Earth's surface received, probably leading to global cooling, thus a catastrophe of a different class. We see this with Saturn. Its ring system very effectively blocks light, which affects how its atmosphere behaves. but also it has what is known as ring rain, where charged water droplets are entering and populating Saturn's upper atmosphere. Earth probably saw a similar ring rain, but instead of ice, it was rock and dust. It also would not have been as extensive as Saturn's rings. That's a shattered moon, most likely, whereas Earth's ring would have involved far less material. But the ring hypothesis actually has more evidence for it. Isotope ratio studies used to indicate past water temperatures on Earth and sediments shows that there was indeed a strange supercooling period right about the time of the ring's proposed existence. There was effectively an ice age during this period, but it's a paradox because Earth's carbon dioxide levels were high and should have done the opposite and warmed the planet, supporting some other influence such as a ring being involved. It's very likely that this abrupt change in temperature and climate caused massive death anyway, possibly more than what would have happened had the asteroid just hit intact. And it just so happens that there was a mass extinction about 445 to 443 million years ago, when 3/4 of Earth's marine animal life died out. Then it abruptly warmed again, about 444 to 437 million years ago. Again, right about the time the proposed ring would have existed and then fell. That extinction, however, was also followed by a huge surge in biodiversity. The point is, a suddenly forming ring system around your planet is an extinction-level event and a true catastrophe. Oddly, however, it can also be envisioned as a way to mitigate a warming planet. You just pick an asteroid of the desired mass, send it on the right trajectory so it gets ripped apart and forms a ring, and it might solve your problem, at least for a time. Or it could make it worse, since not all of the rapid direct effects of something like that are known. Not the last of which is missing the mark and ramming the asteroid directly into Earth. Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently remarking on the hubris of the Ordovician trilobites. It's a good bet that in their profound aloofness, not a single one of them ever turned a compound eye to the sky to behold Earth's former ring system. Well, on second thought, they did live at the bottom of the ocean, so I guess they have an excuse. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.